I've built an automatic license plate recognizer for the gate of my house. All of this is done using a Raspberry Pi 5. So this is the GitHub repository that I'm using, that I built for this project also. As you can see here, there are 4 scripts, Python scripts, and there is a description here with explaining briefly what every script does. And the current script that I'm using is fast_current.py, which I'm going to explain to you guys how it works. So we have here our libraries, which I'm going to skip, and then we are going straight on to set up the Telegram bot, which I am also not going to show you guys how you build a Telegram bot. It's pretty simple and straightforward, but you need a unique bot token and share ID so you can have conversations with the bot. When you pass on to relay on GPIO pin 17, which in reality, or in the Raspberry Pi 5 hardware, it's pin 11. We need this to send electric signal to the relay, so then it can open the gate. Then we initialize the ALPR model once. We have here the detector model that detects the license plate in the cars, and then the OCR model that extracts the characters from the license plate. Pass on to allowed license plates, which are, it's like our database. It's just simply a Python dictionary with all the characters from the license plate that need to be detected. Then we pass on to RTSP camera stream. So the way that I did this project was to connect the camera to the Pi, or the Pi to the camera, I use the RTSP protocol. And the camera that I'm using is also a TP-Link Tapo TC41. And to achieve this URL, you need to go to the camera app, go to advanced settings, enter a username and a password that you need to put here. And also you need to get an IP address, which I recommend you guys to get a static IP address, because every time you turn on and off the camera, the IP address just changes. And to avoid that, to avoid also changing here the IP address, you just use a static one. Now we pass on to cooldown time in seconds, 3 minutes, trigger cooldown equals 180. I added this feature because every time 2 cars try to come inside the house, what happens is that in the second car, the camera reads the license plate, and the Pi sends a signal to the gate board, and the gate will not open, but the gate will stall in the position that is in. And to avoid these conflicts, I added a trigger cooldown, which is 3 minutes of duration, which basically shuts down the code for 3 minutes. So anytime somebody walks in the house through the gate, recognizing with the license plate, the code simply shuts down for 3 minutes. Then you have here frame skip equals 5, only run ALPR every 5th frame. This is just spare the Pi a little bit because it's running 24/7, and what happens is that the Pi is always doing inference in each frame that the camera is displaying. So with frame skip equals 5, we also get our difference in real time, and also will spare a little bit of a Pi in terms of energy, memory, and CPU, GPU usage. Now we go on with the functions. There is a function send messages, which will enable us to get messages from the bot in the Telegram app. We have here Pi status, which sends this info will be used to send a message with the Raspberry Pi hardware info. Then we have here open camera. I added this feature because in the early stages of development, what happened was that the camera, for some reason, it will shut down. Maybe because the internet connection where the Pi is located is not pretty good. But the camera shut down and it didn't restart. So to avoid that, I built this function which automatically reboots the camera, and we also get a message every time that happens. Then we pass on here into actions. These actions will enable us to send a message to the Telegram bot, and the message will do actions. As you can see here in the OpenGate function, we type in /open, and then the gateboard. What happens is that the bot will open the gate, and we also get a message replying to that action. Again, for status, the same thing. We type in /status, and we get the message with information of the Pi hardware info. We also get a message anytime the Raspberry Pi reboots, and then we enter here the main loop of the project. As you can see here, the model is always doing inference, and anytime a license plate is detected, we extract that plate text, and then we see if the plate text belongs in our database, and if the confidence is above 0.88, what happens next is that the gate will open, the relay is open, and then we also get a messages for the corresponding card that opened the gate, and the current time step when that happens. And this is a code, pretty simple, and for now it's working pretty good. Here we are at the gate. I'm going to show you guys the hardware for this project. This yellow box is where the camera is located, and this little box right here, if we open this handle, this is where the hardware or the core of this project is located. As you can see here, we have the Raspberry Pi 5, which has a heatsink and a fan, and also a custom made 3D print case for the Raspberry Pi that a friend of mine gave me. As you can see here, this white cable, I had to drill a little bit of the case to put it in the relay. The relay is just a simple relay from Arduino starter kit. We also have here the power for the Raspberry Pi, power for the camera, and all the power is coming from this little cable on here. That's why you have all these three connections here. Also, the cables for the sockets were really reused from two microwave that were going to the trash, and we could reuse them. And this white cable again is responsible to send the electric signal from the Pi to the relay, and the relay sends the signals to the gate board via these two little yellow and brown cables that go to this pipe right here. Following the pipe, as you can see here, we have the gate board. The gate board is a Proteco Q60A, and when I was reading the gate board manual, it said that terminals 1 and 8 were responsible to perform a starting maneuver of the gate, and that's what I did. I plugged those cables, the 1 and 8, in these terminals, and that makes the gate open. Now I'm going to show you guys how the Telegram bot works. So here we are at the Telegram app. As you can see, we have 3 chats. The bot father is where you configure your Telegram bot, and this is where you get your credentials. And then we have the gate control bot chat, which when we open, we can see the messages that we can send and receive. If I scroll up, you can see we get a message every time the camera is connected, and also every time the license plate is detected and the gate is open. You can see here, gate open for plate, etc. at the current date and time. Now, we can also type in an action that gives us the current hardware info from the Raspberry Pi, and as you can see here, you have the CPU usage, the RAM memory, the disk usage, and also the temperature that the Pi currently has. Going back here, we also have another group chat. When you open it, in this group chat, you can add your members of the family, and if you add also the bot to the group chat, the other members of the group can leverage the bot actions. To finish the video, here's just a clip of me opening the gate at night. And yeah, this has been the project. Let me know if you guys liked it and what other improvements can I add to this project.